What we're going to do is we're going to derive the formula to find the angle between two vectors. In this instance, we've got two vectors, A and B, and we're going to find the angle in between A and B, shown here. What do we want to call this angle?
Beta.
Theta. Or theta, or theta. Okay, now to do this, what we're going to do is we're going to use a familiar rule called the cosine rule. Does anyone remember it?
A plus B.
Yeah, it's on the formula sheet, but it's also useful to just know it off by heart. It's c squared equals a squared plus, finish the rule, Vine. You done Pythag yet?
Nah.
Okay. B squared. So c squared equals a squared plus b squared. And then we add something extra to it. A pinch of speciality.
That's pretty special. Holy.
2ab equals c. So it's just Pythag with a little bit of extra onto it. Now, if we're going to use the cosine rule, that means we need a triangle. How could we make this a triangle? Well,
Close it up.
close it up.
Actually,
Does anyone remember what this vector is to go from here to here?
B take A.
Yeah,
oh,
A take B. Or B take A. It doesn't matter which way you go, so long as it's a triangle. So to go from here to here, we go against the current of B and with the current of A. So it's minus B plus A, or A take B. So there's your triangle. Labeling this in the convention of non-right angled trig, AB, side C, and this would be angle C in there as well. Does that make sense? So if we put this together, what we end up discovering is that our C squared is going to be A take B. And remember, we're using the modulus because we're not talking about direction here, we're talking about length. A take B is equal to the length of side A squared, the length of side B squared, take 2A B, so the length's there, cos theta. Next, we're trying to find the angle. So what I'm going to do is I'm going to rearrange it slightly. I'm going to get this and move it over here, and I'm going to get this and I'm going to move it over there. So we're going to have 2A B cos theta, and then this moved to this side, so we've got these guys. Take this guy. It's at this point we have to start looking at our rules. First thing we need to sort out is this guy in here. Is there a rule we can do to expand that out into something more usable? Rule 2. So expanding this out, I guess I've got to work here. What we're going to discover is that 2AB cos C is going to be equal to the length of A, all squared, plus the length of B, all squared, take, and then we're going to expand it using this guy here. So this turns into that. So it will become, the length of A, I guess it should be in the modulus still. A take B. Yep. Dot A take B. Does that make sense so far? All right, next step. you're going to see that these are in parentheses. They're in parentheses, these ones are in modulus. It doesn't actually matter because we're talking about side lengths. So we're going to use, where are we? This rule here and expand it out here. It's sort of like dots when we do the expansion. So that goes on that goes on that to that, that to that. So bang, 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 bang. So expanding this out and remembering to keep the negative sign. It's going to be a squared. Oh, I guess I can't do that. Yeah. It's going to be a dot a. Then we're going to get a dot negative b. Then we're going to get, in fact, we'll get rid of these because we don't need them. We're going to get negative b dot a. And then we're going to get negative b dot negative b. We okay with that so far? Next rule, these are going to be caught up in rule number 2. This was rule 1, 2, 3, 4. This is going to be caught up in rule number 2. And that one's going to be caught up in rule number 1 and rule, it's just rule number 1. So expanding this out, we're going to get same as before. These just come down. This is going to become minus a all squared. Then this one is going to become minus b all squared. And then because we can swap these around with no consequence and bring the negative out front, we're going to get 2, then a dot b. Is that all right? These all cancel. So we end up getting negative 2 a dot b. Then over here we're going to get 2 a b cos theta. And I've made a mistake
If you bring the
somewhere.
negative out to the front, wouldn't they cancel out? Because
Yeah, you're right. That comes out the front, so that's actually a plus, negative, and then the negative's there. Good catch. Bringing this over here, we divide both sides by AB. So we're going to get cos theta is equal to A dot B. The 2's cancel. A, B. Hence, the angle of interest is going to be the inverse cosine of as shown.
Is that like an actual testable derivation?
Yeah, it is actually. A few years ago, a similar rule popped up that required you to use the identities up here. So that would be fair game. I don't think it would show up.
Not really, so.
The thing is, it could show up, but whether it would show up, unlikely, in my opinion.
Can't you just say that about every question? Can't you just say that about every question? It's unlikely to show.
No,
Or
no.
there's some like 100%.
I just don't think you would get asked to do that in either the SAT or the external, but the point is they could ask you to do it. My thoughts are it's too novel, or sorry, not too novel, it's too low hanging on the tree.
Oh, so it's easy pickings.
Well, I think it would be easy pickings because if I ask you to do that, you could probably do it. Once you see it, you don't unsee it. Does that make sense? So this shows us the angle between two vectors. Now the application of this is suppose we have vectors on the screen. I am going to show it as switch it. Boom. Suppose we have two vectors shown on the screen like this. Do you see how they're floating in space? So vector 1 and vector 2. We're actually able to see the angle made between these two vectors, but it's a little bit difficult because they don't cross at all, do they? They don't touch. But remember, these are position vectors. They're the vector between points C and D and A and B. If we wanted to represent these, not as position vectors, but as direction vectors, I can enable it like this and like that. So they're still the same vector. It's just its tail is starting from the origin. So we'd be looking at the angle between the two vectors connected tail to tail. Now, as a sneak peek, if you just wanted to get the angle, then cool tools like GeoGebra can do it.
There's a whole group all down there.
And really cool tools like our calculator can do it as well. Now, to be able to do this in our calculator, we just say up and come, we go to options,
Peanuts.
calc, sorry, not options calc. It's options, map there, we go across, oops, and it's just the angle of the shadow over here. It's the same application as the dot product, you just put it in with a comma in between. I don't think we need to do one of these, because if you can do the dot product, then you can find the angle. Are we happy with that? So it is possible to find the angle between two skew vectors in space. So two vectors that don't actually meet, you simply grab them, and rather than being position vectors, you put them together and you represent them as direction vectors from the origin. So the origin being there. Is that alright? Awesome.